looking at the transformation as we square root the sine x, we have to think of how the square root transforms functions. And basically our reference points are going to be when the original function is equal to 1 and where the original function is equal to 0. And we can see that when we square root 1, that blue line represents the square root of sine x. So we square root 1, we get 1. We square root 0 and 0, we get zeros. Now, because we are square rooting values here between 0 and 1, the square root of a decimal number is bigger, so we get this kind of bump up. So we get this blue function here happening when I square root sine x. And we also have to take out the domain of that. So this part here, that domain where the inside function is negative, we can no longer have that when we have the square root. So we can use graphing technology so we see what the graphs look like here. For part C, how do you think the graph of square root sine x plus 1 is going to differ from square root sine x? Well, when we take a look at the square root of sine x plus 1, we first have to do the vertical transformation. So we get a vertical shift of plus 1. So we get this curve here. Okay, so we have value of 2, R1, R0, R1, R0 points. And we can see that when we square root those points, we still have our references of 0 and 1, but now they occur in different places. And so you can see that the square root of 1 and 0 stays the same. They're invariant points. And as we square root values that are less than 1, we get this bump up. Values bigger than 1, these points get compressed down. So here's our value of 2 square rooted gives us about 1.41. So this vertex point gets pushed down to here. Okay, so because of the fact that we have this vertical shift first, we now change the locations of our reference points here, 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 and here, those points in black. And those become our invariant points.